Hi Math 9s, welcome to this week's video all about the properties of angles in a circle. So this is going to keep building on what we've been talking about. So for circle geometry, we've talked about tangents, we've talked about chords, and we have kind of been talking about angles. We've been solving some problems where we have to find missing angles, but we're going to take that just a little bit further. So just to quickly review a couple things that we should remember from previous grades. When we're talking about angles, there's a couple things to keep in mind. So if I have, let me get a pen here. If I have a triangle, I know I've talked about this in a couple other videos, but just to make sure, sometimes we can have a right angle. So if I had a right angle, remember that means that it's 90 degrees, and I would use this kind of square symbol to show that. And then remember as well that the angles in a triangle add up to 180 degrees. So if I took this 90 degrees, whatever this angle is here, and whatever that angle is there, they would total up to 180 degrees. Something else to keep in mind, if I have a straight line, pretend that's straight, and I was looking at the value of this angle here, that's not what I meant to do. That's what I meant to do. That angle there, remember a straight line is 180 degrees. And if I looked at the other side of the straight line, that is also 180 degrees. That brings us to the last thing. If I have a circle, and we'll see this in a couple examples, remember that a full circle is 360 degrees. So all the way around there is 360 degrees. So if I split this circle up into a couple different sections, pretend the center is there, something like that. And I added up that angle there, and that angle there, and that angle there. They would all add to 360 degrees. So these are a few tools that we should have remembered from previous grades that will help us when we're solving some of these problems today. So let's jump right in. Our first new definition for today, an arc. An arc is a section of the circumference of a circle. Circumference shouldn't be a new word to us, but if it is, remember circumference of a circle is just the distance around the outside. So if I take a section of the outside of a circle, I call it an arc. So as an example, if I go from point A here to point B there, I'm just going to use my highlighter tool. I can look at this and call it an arc. And I would call this arc minor arc AB, because it goes from point A to point B. There is also a major arc AB. And you can probably guess where that would be. It's still going from point A to point B, but it's going around the other way. So that there would be major arc AB. In grade 9, 99% of the time, we're going to be talking about the minor arc, so the shortest distance between the points. You might come across a question where it's talking about a major arc, but that is very unlikely. So in grade 9, we're mostly just focused on minor arcs. So if I take an arc, let me just sketch an arc onto this circle here. So here is minor arc CD. So it would be this section here. If I take the endpoints of these arcs, so from point C and point D, and I attach those to the center of the circle, so if I join the endpoints of this arc to the center of the circle, bear with me, I know my lines won't be straight, but I'll do my best. So if I go from C to B, or C to the center, and D to the center, I end up with an angle formed in the middle here. And that angle there is called a central angle. So that's a really important definition for grade 9. So a central angle, if I take an arc and I connect the endpoints of the arc to the center of the circle. We can also do something that's similar, but not quite the same. So I'm going to just kind of sketch out C and D again. So I'm looking at minor arc CD, just like in the last one. But this time, instead of joining the endpoints to the center of the circle, I'm going to join them somewhere else on the circumference. So what that might look like is it might look like me going from point C over here, and then point D to that same point. It also could look like going from point C over here, and then point D to the same point. So I end up with an angle being formed there, and if I look at the blue lines, an angle being formed there. Those angles are called inscribed angles. And there's a relationship between our inscribed angles and our central angles. So remember, if the lines go from the edge or the end of the arc to the center, it's a central angle. Listen to the name. If they go somewhere else on the outside of the circle, it's called an inscribed angle. It's really important that we understand the difference between those two angles. One other vocabulary word that we need to make sure that we understand is the word subtended. So you might see in a question, I say that the inscribed angle is subtended by arc AB. All that means, subtended sounds really weird, but all it really means is formed or made. So when I say the inscribed and central angles in this circle, so there's the inscribed, there's the central, in this circle are subtended by the minor arc AB. All I mean is that the inscribed and the central angle are formed by arc AB. So it tells you what arc on the circumference is creating the angle. So if you see that word in a question, don't let it freak you out. Now you know what it means. So the first thing that we need to understand with our central and inscribed angles, in a circle, the measure of a central angle subtended by an arc is twice the measure of an inscribed angle subtended by the same arc. So all that means is if I have an arc, I will draw my arc up here this time. So there's my arc. I'll highlight it so you can really see. I'm going to call that arc XY. So the measure of a central angle subtended by an arc. Okay, let's draw a central angle. I'll call this angle Q. So the measure of a central angle subtended by an arc is twice the measure of an inscribed angle subtended by the same arc. So then if I draw an inscribed angle like this, I'm going to call this angle R. And notice I use different symbols on my angles because they're going to be different sizes. And we have a relationship. The central angle is twice the measure of an inscribed angle. So all that means, all these fancy words, just means if we have an arc with a central angle and an inscribed angle, the central angle is going to be twice as large as the inscribed angle. So I could write out a mathematical statement for that. I could say angle Q is twice the size of angle R. I could even say angle Q equals 2 times angle R. So for example, just random numbers that I'm going to make up, if angle Q is 90 degrees, angle R would be 45 degrees. And this always works. our second rule for today is in a circle, all inscribed angles subtended by the same arc are congruent. So let's start out with an arc. I'll put my arc over here this time. So I'm going to use this minor arc, and I'm just going to draw some inscribed angles. So I'll make maybe a blue one over here, just to help keep you straight. I'll do a green one, maybe over here. And I'll do a yellow one, maybe off to this side. So I have 3 inscribed angles. One here, and one here. The thing we have to remember about this is that all of those inscribed angles, as long as they're coming off of the same arc, they are congruent. And remember, congruent means equal or the same. So if I said that this angle here, this blue one, was 15 degrees, the green one would also be 15 degrees, and the yellow one would also be 15 degrees. You just have to make sure that they're all coming off of the same arc, that they're all subtended by the same arc. What about a semicircle? So what if I had my arc, 1 point there, 1 point there. So my minor arc was actually half of the circle. And then what if I drew a central angle off of this arc? Well, my central angle would be that angle there. And guess what? It's a straight line. How many degrees are in a straight line? Well, 180. So in a semicircle, my central angle is 180 degrees. What about an inscribed angle? Well, let's just draw one. Let's draw one to this point, and I'm going to try to use my line tool so I can make it more accurate. Oops. There we go. That's not bad. So again, remember I'm doing this by hand, so it's not going to be 100% perfect, but if you take a look at that angle, it looks like a right angle. And if you think about the relationship between the central and the inscribed, remember the central is double the size of the inscribed. So if I took the central, 180 degrees, and I divided it by 2, or split it in half, that gives me an inscribed angle of 90 degrees. So my inscribed angle is 90 degrees. So in a semicircle, the central angle is always, always, always 180 degrees. The inscribed angle is always, always, always 90 degrees. And this will help us with some problem solving, especially when we remember that Pythagorean theorem can be used to find the missing sides in a right triangle. So there's another tool we can put into our pocket. And this is just summarizing what I just wrote out for you guys. So all inscribed angles subtended by a semicircle are right angles. So if this is my arc AB, I have an inscribed angle there, there, and there. And notice they're all 90 degrees. They are all right angles. All right, let's look at an example. So point O is the center of a circle. Okay, we should be pretty used to that by now. So there's the center. Maybe I'll just put a red dot there so I can keep track. Determine the values of x degrees and y degrees. So there's 2 missing angles. There's angle y, there's angle x. I'm trying to find the values of them. All right, they also gave us this angle over here. And one thing that sometimes your brain just takes some time to start seeing, this angle here, 55 degrees, is subtended by arc AB. So there's my minor arc AB. So I should probably be seeing if I can use that arc to solve the other problems. So if I'm looking at 55 degrees, this is an inscribed angle off of arc AB. So I'm just going to label it with an I. That might be helpful. I don't know. So I'll just label this inscribed. So an inscribed angle here is 55 degrees. Something that you also might have noticed is that off of arc AB, there is another inscribed angle. Maybe I'll just highlight it in green compared to that inscribed angle there. Well, I know that any inscribed angle off of the same arc, subtended by the same arc, is going to have the same value. They are congruent. So that means if this angle over here is 55 degrees, angle X is also 55 degrees. Awesome, nice job. If I'm looking at angle Y now, you probably noticed it also comes off of arc AB, but instead of going to the edge of the circle like the other inscribed angles, it goes to the center. So Y is a central angle. I'm just going to label it C for central. And if it helps you to maybe highlight it in a color, that could be helpful. So angle Y is a central angle. And remember, central angles are twice as big as inscribed angles, as long as they're subtended by the same arc. So to find angle Y, I need to take angle X, multiply it by 2, so 55 times 2 gives me 110 degrees. There you go. Our second example. Rectangle ABCD has its vertices on a circle. Okay, so there's a circle. I don't know about you guys, but it looks like an optical illusion to me where it's kind of like bubbling out, but whatever. So ABCD has its vertices on a circle. So its corners are on this circle. The circle has a radius of 8.5 centimeters. And they've labeled that for us. Nice, nice. The width of the rectangle is 10 centimeters. Okay, they labeled that for us there too. What is its length? And then we'll have to round our answer to the nearest tenth. Okay, what is its length? So we are trying to find, let me just get my highlighter. We are trying to find the length. So this side here, one of the long sides. Okay, I'm going to label that question mark. Beauty. So I know that this side here is 10. Okay. I know that this here is 8.5. Now to find the missing lengths of things, literally, really, the only way we've been finding missing sides is by using Pythagorean theorem. So a missing length, we're going to use Pythagorean theorem. Whoa, Pythagorean theorem. So that means we need to make a right triangle. Well, let's think here about arc maybe CA. If I use a central angle for CA, that gives me a 90-degree inscribed angle. So that would create an inscribed angle there. Well, let me just sketch in the rest of this. So what if I close that up and now I have a right triangle? And I know that because, I'll highlight it on the other side. If I use arc AC, it makes a semicircle, which gives us inscribed angles of 90 degrees. Cool. Also, it's a rectangle, so that helps you as well. All right, so if this side for the radius was 8.5, then that means that this side here is also 8.5. So I'm just going to add that together, and I'm going to get a total length of this side of 17 centimeters. So before I do any math, I'm just going to sketch out that triangle again, just so that we don't get too confused about what's going on. So there's my 90 degrees. Here is my missing side, which I'm also just going to call A for Pythagorean theorem. I have 10 centimeters. I'll call that B. And then I have 17 centimeters, which is my C. So by now we should be really, really familiar with Pythagorean theorem. So I'm going to go the square root of C squared minus B squared, because I have my hypotenuse. So the square root of 17 squared minus 10 squared. Bear with me while I punch that into my calculator. So I'm going to take the square root of 17 squared minus 10 squared. And that gives me a value of 13.747 centimeters. Now, if I think about that, remember it's my length, so it should be longer than this 10 centimeter side that they gave us. 13.7 something, yeah, that's longer. So I probably did it correctly. So they've also, if I go back to my question, we want the answer to the nearest tenth. So that means 1 decimal place. So my final answer, I could say length is 13.7 centimeters. Remember, the 4 means that the 7 stays 7. So my final answer, 13.7 centimeters. Last example for today. So triangle ABC is inscribed in a circle. ABC, okay. Just that triangle there. So angle AOB is 100 degrees. AOB, okay, so they've labeled that for us. Angle COB is 140. COB, 140. Perfect. They labeled that for us there too. Find the values of X, Y, and Z. So we're trying to find 3 missing angles this time. All right. One thing I really want to emphasize with these questions is that there are multiple ways of thinking about them. So if you're getting the same answer as me, really for any of these questions, but you're doing it a different way, that's okay. In this question alone, there's probably 3 or 4 different ways of finding some of these values. And I'm just going to show you the way that my brain sees them first. And then if you have any questions afterwards about whether the way that you found it works, feel free to send me an email. But I will almost guarantee you, as long as you're getting the same numbers as me, you are just fine. All right, so I'm going to start with angle X because I know, because I've done this question many times, that that's the easiest place to start. And something about these problems is that you just kind of have to look at them and get a feel for where you should start. And it doesn't hurt just to try something and see how it goes. All right, so angle X is this little area that I've highlighted in blue. So remember at the beginning, I reminded you guys that a full circle is 360 degrees. And what I actually have here is 2 parts of that. I have 100 degrees here. I have 140 degrees here. So if I find the difference between those 2 values and 360, it'll give me the leftover piece that will be angle X. So let me just erase that mess that I just drew. So angle X is this angle here, and to find it, I need to just go 360 minus 100 minus 140. So if I do that, I end up with, I'm just going to use my calculator because it's Monday morning and I don't trust my mental math. X equals 120 degrees. And then I can double check that by adding all 3 of those angles inside the circle together to make sure that they actually equal 360. Okay, perfect. And then I'm actually just going to go in and I'm just going to label that 120. All right. So now, Y or Z, you could probably do either of them now. I'm going to look at Y. And notice here that Y is actually both sections here. Some people, when they look at that, they think that it's just this part, but it actually includes that little bit there. So you have to be careful. All right. Well, I am noticing that angle Y is actually an inscribed angle off of arc AC. Hopefully you guys can see that there. There's an inscribed angle. I also have a central angle from that same arc. And guess what? I know the value of it. I know the central angle, which is angle X, is 120. And I'm trying to find the inscribed angle. So remember, our inscribed angle is half the size of the central angle. So all I need to do is go, let me zoom back out. For Y, Y is going to be half of 120, which gives us 60 degrees. So Y is 60 degrees. Nice. All right, now we have angle Z. So for angle Z, hopefully you notice that it's part of what I'm just going to complete here in blue, an isosceles triangle. So those 3 blue sides, and I know it's isosceles because this side and this side are both radii. So they're going to be the same length. That means that angle Z and this angle over here by A have to be equal. If those 2 sides are equal, the 2 angles have to be equal. So if I take, remember, the interior angles of a triangle add up to 180 degrees. So for angle Z, if I take that 180 degrees and I subtract the angle that I know right here, 120 minus 120, that leaves me with 60 degrees. Now that 60 degrees has to be split evenly between this angle here and this angle here. So if I take 60 degrees divided by 2, I end up with 30 degrees. So angle Z is equal to 30. Now one thing, again, remember, I mentioned it, I ranted a little bit. If you're getting the same numbers, but you're thinking about it a different way, that is A-OK. However you figure it out is fantastic. So if you guys have any questions about that, please shoot me an email. I will also be uploading a video tomorrow of myself working through the practice questions. So if you have any issues with that as well, make sure you watch the video and then let me know. Remember, I am happy to help, and I'm just an email away. Thanks, grade 9s.